Hello, good afternoon. I'm here. I'm not Martin Ganholm. I'm Evan Anderson, but I'm one of the tech leads on the Google Compute Engine team, and I'm here to talk to you about the Google Cloud Platform. In particular, Google Compute Engine and Google Cloud Storage. I will mention a few of the other things we've got in our cloud platform as well. Google's building a cloud platform with a lot of different pieces of infrastructure that you might end up being excited about or interested in. The core pieces of our infrastructure are listed here, but we've got a lot of other functionality that we're adding, things like the translation API that you may find to be a useful addition to your product. These are all designed to work independently. If you start using translation, you're not going to be locked into having to use Compute Engine or App Engine or put your SQL in Google's Cloud SQL. But on the other hand, if you want to have if you want them to work together, they work together quite smoothly and nicely. And the goal is, we want to provide the infrastructure that you need. So if you find that, hey, we're missing a piece, we've got a booth downstairs. A bunch of our marketing guys would be glad to talk to you and find out, just what you're dying to get access to. So on the compute side, you can see that we've got two offerings. You've probably heard about App Engine for a number of years. Write your code for Google's platform, and then put it in Google's cloud, and Google will serve it for you. You won't have to worry about uptime and things like that. On the other hand, that takes away a lot of control. So we've also introduced last year Google Compute Engine, which is a infrastructure as a service where you can get things like virtual machines and so forth. We're also offering cloud storage, and we've got, this is an example application flow for how you can build using, data flows and analytics using Google's cloud platform and also third parties like Tableau. We've got a bunch of different data stores, a bunch of different methods where you can do your own custom analysis. But then we also have tools like Google's BigQuery based on Dremel, which allows you to take terabyte data sets, 5 or 10 terabytes, and run SQL-style queries over them and get back an answer in 10 seconds. Things like that can be transformative when you want to kind of play with data and understand what's going on here. I've used this on Compute Engine to understand various problems that we've had related to network traffic. And when you've got all your network flows in one place, you can run interesting queries over them. And then when that doesn't work, 20 seconds later, come up with a new query, and that solves what's going on. So I'm going to start with Compute Engine. This is the RightScale conference. You're probably interested in infrastructure. You're probably interested in big computation. Google Compute Engine is designed for big computation. You want to run lots of data really fast. You need lots of storage. You need fast networking between machines. Scale, that's another thing that Google's sometimes known for, and we've built Compute Engine with the idea that this will be a platform not only for everyone else outside of Google, but also that you can build Google-sized solutions inside, running in Google proper. So I'm going to talk a little bit first about how to orient yourself if you are new to all of this. Probably, since you're here, some of this will be familiar. We think we've got a couple of unique takes on a few pieces. So to start with, everything is built on top of the same API. It's a JSON REST API using OAuth. So we've got 3 examples on the left of how you can get in. We offer a command line tool. There's a bunch of different UIs available. Compute Engine has one that we offer. RightScale also has a UI, and it's actually pretty nice. So that API is built on, or that UI is built on exactly the same API Google is using. There's no sort of internal secret magic. And then lots of people have written their own code, but we offer 10 different languages libraries for, and I've known 3 or 4 people who've just gone and written their own because JSON's easy. You can just slap something together on your own, and you don't even have to use our language bindings if you don't want to. So here's a little example. But the key thing is we're building our UIs honest, same methods you can use. It's making calls that, this is all built on App Engine, and, you could build your own replacement UI also built on App Engine. So that's great. We've got APIs. What else? Well, you're probably interested in the virtual machines we're offering. So we offer from 1 to 8 CPUs. We offer 3 different memory sizes, and you've got root access. So you can install, any of the software you want and so forth. It's not locked down the way that App Engine is. If you've got crazy code, Fortran, whatever, bring it, we'll run it. So VMs are interesting, but only when you can get data in and out of them. All the computation in the world won't do you any good if you can't go look at it and do interesting things. So we offer, basically the standard, hey, external internet connectivity, using Google's big fat pipes to the world. You can use those to, interact with other services and Google services and non-Google services. And we offer built-in firewalling because the internet's a scary place and you really don't want to go out there without a firewall. Internally, we offer something that's a little bit interesting and different. Every project, which is basically all of your VMs and other associated stuff, gets its own private network, just for you, worldwide. Your own internal DNS naming between machines. So if you log into one machine and you want to connect to another one that you called bar in the API, you just type SSH bar and off you go. We've hooked stuff up inside the guest OS to make it really easy and seamless to work with SSH authentication. So you shouldn't see any passwords in sight once you've authenticated to Google once. So that's really handy and keeps you from having to worry about bad passwords and too many passwords getting around and things like that. Of course, if you love passwords, you've got root. You can change it, but secure by default seemed like a better way to go than encouraging, internet don't do thises. So we've got 3 different storage options, as you can see here. Persistent storage or persistent disk is triply replicated in the same zone that your virtual machines are in. It's built on the same technology that Google uses internally for storage. You do have to pay for the amount stored there, but on the other hand, even if your VM goes away, you've still got your data. It's great for your databases. It's great for your your operating system and stuff like that. But sometimes, you're running HDFS or something like that. You just want cheap storage. So we also offer local disk as scratch space. This is not replicated, and it goes away when your VM dies. But if you've got data that, I care about this a little bit. I want to write it down, but I don't care so much that I can't recreate it. Scratch disk is great for that. And then if you've got data that you want to share with the rest of the world, cloud storage is great for that. It's a blob store, so keys and values. And it can store anything from single bytes up to terabytes of data. Of course, since you've got internet access, you can put things in App Engine, Cloud SQL, your own data stores. So you're certainly not limited to our disk options. Another thing that we've found at Google is that isolation between workloads is the key to having predictable performance. So one thing that we really focus on and that our test team really rakes us over the coals whenever they can find a spot where we've missed it is isolation for performance. So CPU, network, persistent disk, scratch disk. If you buy a 4 and 8 CPU machine, the spindles you get are dedicated. No one else is going to have access to them. So you get every single IOP you can get out of the hardware. Private networks, again, you don't want to have other traffic bouncing around, poking your machines and so forth. We encrypt all data that's stored to those disk solutions at rest, both the persistent disks and the scratch disks. So when you write something to disk, you know that it's been encrypted and that people can't go snooping around on disks and find out what's there. So yeah, we're building consistent, reliable, isolated virtual machines so that you don't have to worry about oh, hey, do I have noisy neighbors? Do I have to worry about things like side channel attacks and so forth? We're trying to build infrastructure that saves you from having to worry. Another example of saving you from having to worry is we've built this service account system which lets you use OAuth access credentials to automatically authenticate from Compute Engine VMs or from App Engine apps to other Google APIs. I'll show you a demo later of App Engine calling Compute Engine. In this case, it's using my OAuth credentials, but you could also build it so that you had a console that authenticated users could log in, and then that App Engine app had permissions to start up or shut down your machines or take disk snapshots or other things. So some of you may have seen our Google I/O presentation last year. A few things have changed since then. One thing that hasn't changed is that we're still in beta. Google has a bit of a reputation for keeping products in beta for a while until we're really confident and solid that they are the best thing out there. But I'll point out, we have dozens of Google projects who've decided that Compute Engine is the right platform for them. So while this is beta, it's beta that we're using actively internally. We're building it to Google standards, so multi-zone, multi-server architectures are highly recommended. The big gotcha that we're not happy with, but is a reality right now, is that we have these scheduled maintenance windows. For up to 2 weeks every 20 weeks, each zone separately may go into maintenance. But using tools and things like RightScale, it's pretty easy and quick to migrate your entire deployment from one zone to another. I think someone was telling me earlier it's something like 17 minutes to move a full application deployment from one zone to a different zone with RightScale. So RightScale's awesome. So now on to the new, exciting, awesome stuff. When we launched, you had one option for amount of memory. Now we have three amounts of memory for any given CPU size. We've also slipped in a discount on machines that don't have scratch disks. You don't need it. You don't pay for it. And everyone's happy. We can move external IPs. You can move IPs across zones. You can move IPs across the world, if that makes sense for you. So this is most useful, obviously, if you're serving off of a static IP and you discover all of a sudden machine is having problems, zone is having problems. You can swoop in and move it to a DR site, even if your servers are down. We've added a lot of functionality around our persistent disk product. You can attach and detach them while the VM is running. You can create images from stored disk images and use those to launch a VM. And you can attach the same disk to many different VMs. And I'll talk about that a little bit more in the next slide. So we've also added the ability to take snapshots of disks. So a neat thing that you can do based on this is you can set up something like if you have a whole bunch of shared data, you can write it on one persistent disk. You can either detach it and attach it read-only to many disks, or if you need to keep updating it, you can take a snapshot, create a new disk, and mount that to many VMs read-only, which is great for distributing. Chrome source code is 200 gigabytes, for example. You might not want to download that 50 times, depending on, that's an internal Google project that is using persistent disks in this way to avoid having to do 200 times as much copying. And these disk snapshots work across zones, work across regions. So you can take a snapshot in the US, restore it in Europe, no problem. Sometimes it's the little details that count. So yes, we have an API. If you like writing Python, if you like writing Ruby, if you like writing Java, that's great. Sometimes you just need a quick shell command line. So we've been adding to our command line tools so that you can do things like dump all my instances and then delete them all. We're sorry you didn't like the product, but at least it's fast. And then we've added a bunch of other things. Europe zones, for those of you who have customers in Europe and want to be close, or who have regulatory issues and say, I'm sorry, we have to keep all our data in Europe. We have European zones now. Instance cloning and the ability to move between zones in our command line. RightScale obviously has a very full-featured solution for managing your whole application. But if you're just playing around, it can be nice to be able to say, make a copy of this VM, or I'd like to have this VM over in this other zone because the maintenance is coming up. You can get the serial point output from your VMs. So if you're logging login events, or if you're logging syslog or something like that, you can actually fetch it without needing to log into your VM. And we've been keeping our kernels and images up to date, feeding patches back upstream when we find problems, all the things that you would hope that a cloud participant would do. So it's time for a demo. And if you have Compute Engine access, you can run this yourself. So I logged in already. When you log in, it'll ask, is this app allowed to use your OAuth credentials for Compute Engine? If you say yes, it will take you here. And you can say, oh, hey, I'd like to launch 200 virtual machines. And it will pop up a little visualization that shows you, hey, look, here are all of the VMs that you wanted to start. And the orange, and of course, when I'm doing it live, that's when it pops up. But the orange indicates that the request has been accepted by Compute Engine. The yellow indicates, oh, hey, Compute Engine has actually started provisioning this, and 26 seconds in, we've got one instance running already. And let me go to our Cloud Console. And here we go. So this will show a list of instances that have been started up. And you can see that I've got, well, we won't count them, but there are 200 instances being started up. Here we are a minute in. We've got about 55 running. We may discover one at the end with that internal server error. It didn't get started up. But green indicates it's up and running, ready to run your commands or anything like that. I had a video in case this wasn't working. It took about 2 minutes then. But it looks like we're on track to maybe even do a little better than that. 25 to go. But yeah, so we try to make things fast. Our test team, okay, 137. That's pretty good. So yeah, it's not just launching VMs that's fast, but launching VMs is fast. They all have consistent performance once you've started them up. I'll talk about that a little bit more later. You could also use the command line to look at this, and actually the command line lets you start a whole batch of VMs with the same arguments as well. So you could do that from the command line, but then you get no interesting graphics. So yeah, and so the demo is an App Engine app. So you could easily write your own. So I will start off with a different story about consistency here. So earlier this year, MapR broke the world record for sorting 1 terabyte of 100-byte keys. And they sorted it in 54 seconds on about 1,000 Google Compute Engine servers. And you can see the previous record was done by Yahoo on a dedicated cluster that they built. And this was built using 4 CPU GCE instances, 1,000 spindles, 4,000 cores. And yeah, as you can see, it took them 5 minutes maybe to start up the cluster. And then they could break TerraSort 40 times and shut it down and get charged for an hour. And the key to breaking this sort of record is consistency. They've broken a second record as well, which is minute sort, which is how much data can you sort in a minute. And if you look at their blog post there, you'll see that all of their work was in bringing in the long tail. Because when you're trying to sort a data set this size, you're limited by which your slowest node is. So if all your nodes are the same speed, then everything's great and you go super fast. If one node takes 15 seconds longer, you missed your record. So They chose 4 CPU instances because they had a dedicated spindle, they had high network bandwidth between the nodes, and given their stack, 4 CPUs seemed to be a sweet spot for them. We encourage you to try it out. Sometimes 8 CPU does better, sometimes 4. Some people seem to find that 1 is what their application needs. So, and I just put a point at the bottom. So if you're curious about how we're doing this, we're using Linux C groups, which were developed at Google for exactly these sorts of problems internally, released upstream into Linux, and it works great with KVM and virtualization as well. So, and this is from another article, also about compute engines, latency, network consistency, and speed. You can see on the right-hand side the compute engine startup time latency, but also between regions, high bandwidth, low latency connections. We're trying to help people build the sorts of deployments that we build at Google, where multi-zone and multi-region is not just a nice to have, it's a must-have when you're serving at Google scale. So we want everyone to be able to have access to that same sort of functionality. And with that in mind, multi-site, multi-zone, multi-region, that's a huge pain. But fortunately, you're here at the right place to get tools to help manage those sorts of things. I can't really talk much about Google's internal tools. The problem with them is that they're only for Googlers. And we kind of wish that wasn't so, but we're really happy that RightScale has built public tools that everyone can use because what we have internally works great for Google, but we really can't share it with the rest of the world right now. Some of it is dirty underwear issues, and some of it is just that it's a little different from what everyone else expects, and so it won't play nicely with your JRuby and everything else. So RightScale has been one of our earliest collaborators, and they've done a great job of taking this platform, this underlying infrastructure, and building on top of it a great management facade that lets you work around things like our maintenances and also manage these multi-region deployments that we think are really key to huge scale. So yeah, you can see on the left-hand side, Google, very strongly an infrastructure company. RightScale giving you the management tools you need to make everything work together. So with that, I've talked about Compute Engine. I'm now going to spend a bit of time talking about Google Cloud Storage, which is the other half of our infrastructure as a service offering. And then I will have a bit of time at the end, it looks like, for questions and so forth. And we may have a few other bits at the end. So it's an object store. You've seen them. You write a bunch of bytes at a URL, and then you can get them later. What's particularly interesting? Well, it's got strong consistency. So you write some data, and then you go to read it back immediately afterwards. You'll get those same bytes. You won't discover that it's still waiting to be replicated and the old data's there. It's global. So you can fetch it from anywhere in the world, and it should be fast. It supports objects from single bytes up to terabytes. People have been using it to ship around geographic information data, backups, terabytes of data. I can't say petabytes yet, I don't think, but I can. OK, petabytes of data. So it's built for Google scale. You can serve directly from it if you have static content that you want widely replicated. Cloud storage works great for that. It uses the same JSON and OAuth 2. It has an API that is JSON and OAuth 2. It also has an API that's compatible with other cloud storage providers that use XML and things like that. And we've got an authentication model that lets you delegate individual objects or entire buckets to other users, and the signed URLs are a great choice for certain types of applications where you want to say you're allowed to upload one file, at this time from your phone to this bucket, and then we'll process it. As an example, there's lots of places where sometimes you want to take one file from a customer, but you don't want to give them access to dump as much as you want here on our bill. So how do we do it? Well, sort of the standard Google replicate data lots of places, put it in different cities, put it on different hardware, multiple paths. You probably heard some of this, don't buy from, even if one vendor promises you multi-path, it's even better if you can find two different vendors who can give you paths. Google does a lot of that legwork for you already to deliver you YouTube and Gmail and all the other things, Google Search, that, you just sort of expect it to be there. And we're using it extensively internally at Google for these sorts of things, for shipping data, to or from vendors, for, publishing large data sets. It's rock solid and monitored. There was a great story someone posted recently about App Engine that I saw, where they said, hey, we were using App Engine. We worried about system-wide outages. So we switched to running our own thing. And since then, we haven't noticed any outages because we haven't been monitoring them. That doesn't actually give you more reliability. It just means that you don't know when you're down. So it's great to have someone who's paying attention when you're down and is working to get you back up as quickly as possible. So, and yes, it's scalable on every dimension, both upwards and downwards. You only pay for what you actually store or serve. So if you've got a small website that's all static content, it's got hooks, and you can just put it into cloud storage and then shut down your server and let Google serve it for, pennies a day, pennies a week if you don't have much traffic. And as mentioned, it's a glue. It's how we bring images into Compute Engine. It's how we bring data into BigQuery. It's how we export data out of these places if you want to go and take it elsewhere. And we've, just like Compute Engine, we're not stopping. We're adding new stuff, adding client libraries for App Engine, adding even better static site hosting with the cross-origin resource sharing, so you can actually configure, OK, which stuff is it safe to fetch from JavaScript and so forth while you're using cloud storage to back some of your data. Permission settings, audit logs, we understand that that's important for a lot of people. And we're trying to build a solution where it works for everyone at Google and everyone in the rest of the world. Hopefully, if you've got a need, you're probably not alone. We'd love to hear about it. And that brings to, OK, well, how do I use this? And the answer is similar to Compute Engine, but we also have an XML API in this case that works with Eucalyptus and S3. And all of this works over HTTP. All of this works with OAuth 2. And it should work either from within Google or if you've got your own hosting provider. So you say, that sounds awesome. How do I get it? Well, if you're a RightScale customer, Compute Engine Access is available. If you aren't yet a RightScale customer, you're probably at the right place. We are offering if you're signing up for a support agreement, you may also be able to get it directly from Google. But these RightScale guys are offering you a lot of extra value, and they're waiving the usage charges for the first year. So that's pretty awesome. And I don't know if Hunter wants to stand up, but he's been making this magic happen. So
thanks, Evan. We're really excited about it. Thanks, Evan. We're really excited about it.
And so that's what I had to say about the cloud platform. So it looks like we've got 10 or 15 minutes left if my clock is right, but I'm not sure if it is. So does anyone have questions?
You mentioned European regions. Do you have regions in other parts of the world, APAC, South America?
I don't believe that we do yet.
Any idea when?
So the good news is it's built on standard Google Data Center technology. The good news is it's built on standard Google Data Center technology, so it's fairly seamless to spin up new zones as there's demand. The other things as well, if you're doing things like at exchange bidders, talk to us. There's amazing low latency available in zones outside of what you typically see from the console that will get you right next to the ad exchanges to get you the low latency responses that blow away anything else you can see around.
Question over here. Hi.
Hey.
Moving terabytes of data in and out of Google.
Mm-hmm.
What are the techniques that folks are using to make that fast and reliable?
So I know that one of the things that Google has been doing for a number of years is Google is happy to peer with pretty much anyone who's willing to haul a line to an internet exchange. All right. So that's a great way if you've got the data on premises. If you're connected at some other cloud provider, we don't have, you can certainly ship it over the internet. I don't know if we have other ingestion options at this point.
There's a few options depending on the size of your data.
Okay. Excellent. Somebody who knows what we're shipping
and where
can
do we
answer
learn
that
more?
question.
Contact us. I'll give you my card afterwards. I can connect you. Great. So if you have terabytes of data, we have some automatic ingestion tools that we use across Google for things like maps. Otherwise, if you're looking at petabytes, we have some custom solutions that allow you to import data from wherever it may be, and we can work with you on that.
Great.
Thank you.
All right, I get to keep it.
Hit at least one back there.
For Google Compute Engine, what are the 3 or 4 biggest technical differentiators between you and, say, Azure and AWS?
So I'm sure that I will miss something, and one of my engineering buddies will give me a hard time about it later. I guess one of the key points is I'd say consistent fast performance is something that we've focused a lot on. We think that we do a really good job, but on the other hand, we'd rather that people measure us and keep us honest than to say, oh, yes, we know that we're faster than, because that's a ridiculous game. Beyond that, encryption of data at rest is something that Google takes very seriously. So all of your disk data, when you write it, whether it's to scratch or persisted storage, your snapshots, all of those are encrypted. I think that's a key point. The consistent performance, we think, is really powerful, and I would say that those are the biggest two. There are a lot of little ones that I could point out. The service accounts was one thing that I mentioned, but I'd say those are the biggest.
Your networking friends in engineering would like a shout out as well.
So yes, consistent performance, including consistent networking. Bandwidth between hosts. Several people have approached us at various times with questions about, well, how do I make sure that all of my VMs are sharing the same switch? Our answer is that we will make sure that you get the networking bandwidth you need, and worrying about things like switch topology should really be our concern, not yours. If you find that that's causing you problems, we would love to know, but we believe at this point that that's something that we are providing a good answer to at that scale.
The private network's really cool as well, to be able to just use your instance names as DNS names to address from US instances to EMEA instances. It's just one seamless global private network. You're not traveling over the public internet. You're on Google's fiber network, which enables the kind of things you've seen reported that people have been observing. That's huge.
Okay, well, apparently I managed to get it in within the time frame. Excellent. And I will be down at the Google booth for the rest of today, and I know that we've got people there who will be there tomorrow as well if you've got follow-up questions you want to ask afterwards. And I'm sure Hunter will be around and all that hard work.
Thanks for finding that.